Our video today is going to focus on solving equations that have fractions and or decimals showing up inside of them. I do want to note that the processes that we are going to learn for both of these are optional. These are not required when you are going through and solving equations that have fractions or decimals inside of them, but I do think it tends to make these problems a little bit easier to work with, or at the very least a little bit less intimidating when we take a first look at them and when we go through and actually solve them. So our process, specifically for fractions first, is going to be listed here. Now it should be noted before we jump into these three steps, this is to eliminate fractions after grouping symbols and exponents have been dealt with. So if you are writing this down or taking any notes for yourself from this video, which I encourage you to do, I'd recommend underlining this part right here. If there are any grouping symbols, that could be not fractions, that could be parentheses, that could be brackets, and that could be the absolute value sign. Or if there are any exponents, something raised to the second power, something raised to the third power, the fifth power, etc., then we need to deal with those first, and we need to eliminate them before we go through and do the rest of our process. And how we eliminate those and work with them is just apply PEMDAS, our order of operations, and what we've been doing in the 2.1 through 2.4 material. So review that if you need to for our simplifying each step, or each side of the equation steps. But let's assume that we've gone through and we have no grouping symbols and we have no exponents left over. Then here's the recommended process that we use to get rid of fractions. We want to first determine the lowest common denominator between all the fractions in the problem. So everything on the left-hand side of the equal sign and everything on the right-hand side of the equal sign. What is the lowest common denominator between all the fractions in the problem? Now, very often this ends up being one of the denominators that's originally listed. Sometimes it's a completely different number. It depends on the problem we've been given. And there's nothing wrong with using something that we're originally starting with as a denominator. So don't feel like you've missed something or you need to pick something different if and or when that shows up in these problems. Our next step is that we need to make sure we multiply both sides of the equation, meaning all terms, by the lowest common denominator, specifically to eliminate the fractions. Our entire goal with this is to get rid of fractions so we don't have to worry about them or deal with them at all. So this is the step that we need to do, and we should be seeing as an end result from this, all fractions are eliminated. This does not necessarily get us directly to our final answer, but it at least creates a problem that's going to look closer to like a 2.1 through 2.4 problem. The fractions are gone, and then after that, we solve the resulting equation using our process that we learned from the 2.1 through 2.4 material. You could be asked to classify something like we did in 2.4, and again, I think that classification is something you do at the very, very, very end of this process and the end of solving these problems in general. So we're going to take a look at these two examples here before we dive down to decimals. So I'd recommend, as necessary, pause the video, write this equation down for yourself, write this equation down for yourself, and we'll jump on over and get going on these. Alright, so our first problem that we have here is 1/3 w plus 5 over 4 is equal to w minus 1/4. As we had in our directions, we need to make sure that we have no grouping symbols, brackets, parentheses, absolute value signs, which it looks like we don't have. That's good. And we have no exponents in this problem, so it doesn't look like we have any exponents either, so we're good. We can jump to our first step in the process that was listed on the previous page. So we first need to determine what is the lowest common denominator between all of the fractions in this problem. So I have a fraction here, I have a fraction here, and I have a fraction here. So I need to write out what is the lowest common denominator between 3, 4, and 4. When you do have that figured out, I recommend writing it somewhere nearby for yourself. In this case, it's going to be 12. The smallest number that 3 and 4 can both multiply into is 12. Okay? So our first step is done. Now the second step, multiply both sides of the equation, meaning all terms, by the lowest common denominator to eliminate the fractions is what we're doing next. So my recommendation is rewriting the previous line, but spread these out just a little bit. There's a little bit of space here. We're going to see why in a second. It's mainly to give us some room to actually go through and write some things out, so nothing wrong with doing that if you need to. So now, every single term is going to multiply by this lowest common denominator, and again, my end result should be that the fractions all eliminate and cancel out. So this first term is going to multiply by 12. The second term is going to multiply by 12. This w is going to multiply by 12. And this 1/4 is going to multiply by 12. You may notice that we have a fraction here, fraction here, fraction here, but this w doesn't have any fraction attached to it. That's fine, and there's nothing wrong with that. It still needs to get multiplied by this lowest common denominator. We are effectively scaling the entire problem up to get rid of the fractions. So as a result of that, we should see this number getting bigger, this number getting bigger, this getting bigger, and this getting bigger as well. Nothing wrong with that. We'll deal with it here in a little bit. But just to be aware of that, even if it doesn't have a fraction, it still gets multiplied by that lowest common denominator. Nothing escapes that. So multiplying these things together, you have two choices. You can do cross cancellation here, or you can multiply them together to make a single fraction and then simplify that thing down. I'm going to use that step for this particular problem, and I'm going to show cross cancellation in example 2. So 1/3 w times 12. This 12 is implied to be over an invisible 1. Same thing with this one, and same thing with this one. So if you need to write that in for yourself, go for it. Nothing wrong with that. So I now have 1/3 times 12 over 1. That's going to give me 12 over 3w, plus, this should give me, I believe that's 60 over 4, times, well, that equals, I should say, 12w, and then 12 over 4 right there. All right, now let's simplify each of these fractions down. I have 12 over 3, or 12 divided by 3. That's going to give me 4w. 60 divided by 4. Let's see, doing mental math, and I think it should be 15. Yeah. I have a calculator sitting right next to me here, so doing some number crunching to double check my mental math. And you're welcome to use that as well as you're going through these. And we should see as the end result of this, hey, all of my fractions are now gone. Excellent. We have a problem that looks like something we saw in the 2.1, 2.2 material, or 2.1 through 2.3 material, I should say. And now we can go through and actually just solve this thing with that previous process. So I'm going to subtract 4w from both sides. I want to get rid of the variable with the lower coefficient. I'm going to get 15 equals 8w minus 3. I want to get this w by itself, so I'm going to add 3 to both sides. It's going to give me 18 equals 8w. Now I'm dividing both sides by 8. And I'm getting 18 over 8 equals w. Remember that we always need to fully reduce fractions down. So the numerator and the denominator can both be divided by 2. That's going to give me 9 over 4. And I can't reduce that any further. We don't like mixed number final answers if we can help it, and we're not being asked for that. So 9 over 4 is going to be our final answer for this one. I'm trying to zoom this out here so we can see the whole process. There we go. So there's example 1. Let's go ahead and move on to example 2. Okay, so our second example, we get stuff that's looking way more complex and advanced here. We've got a fraction with weird stuff in the numerator, fraction with other weird stuff in the numerator. So how exactly are we going to go through this? Well, we are going to use the exact same process that we did previously. I'm noticing that I have no parentheses or brackets or anything like that in this problem, so great, I have no grouping symbols. I'm also noticing that I have no exponents showing up. Nothing is being raised to the second power or third power or anything like that. So great, I can go ahead and use the process that we learned and get to my answer here. So I'm looking at my two denominators, 2 and 8. Between those, what is the lowest common denominator between them? Well, that's going to end up being 8. As I mentioned previously when we were going through the notes, there's absolutely nothing wrong with having having the lowest common denominator be one of the originally given denominators. It's actually a fairly common occurrence with a lot of these problems as we're going through them. So again, I'm just going to go through and rewrite the original thing, giving myself some space in and around here to write some extra stuff in. Now I'm going to multiply every single thing, even if it is a whole number, like 1 here. It's all going to get multiplied by 8. And again, my intention is to eliminate the fractions, but that does mean that all non-fractions are going to have to get scaled up accordingly going along with it. So now, this is where I recommend, if we are not familiar with it, using cross cancellations. Very, very useful here, and it's going to save us a little bit of potential headache if you use the distributive property and try and multiply 8 through to everything inside here. If you're thinking of doing that, it's not necessarily wrong, but it doesn't eliminate the fractions in the denominator, which is what we are specifically trying to do here. So I have an 8 in the numerator spot, and I have a 2 in the denominator spot. Noting that both of these things can be divided by 2, I can reduce both of them down by 2. So this 2 becomes a 1, this 8 becomes a 4, so it cancels out there. My new statement is going to be 3x plus 4 times 4. It's on the right side of this thing, but there's nothing wrong with that. Over here, I have 8 times 1. Well, not really a whole lot of mystery going on there. That's just going to give me 8. And on the opposite side, I have all of this divided by 8, and it's going to be multiplied by 8 over 1. I have an 8 in the numerator. I have an 8 in the denominator. Both of these things can be divided by 8, which means they cancel out to both become 1. My new result is going to be this 5x plus 10 multiplied by 1 here. And now, fractions are gone. I can go through and solve this thing just like I was looking at a 2.1 or 2.2 or 2.3 problem. So I'm going to distribute this 4 on the left side through to everything inside the set of parentheses. I'm going to get 12x plus 16 plus 8 on the left side. Anything times 1, that's just going to be the anything that we were given originally. So this right side is going to become 5x plus 10. 1 distributing through, if you do want to write that out for yourself, you can. 1 times 5x, 1 times 10 just gets us what we had originally. Fantastic. Let's further simplify this down, specifically this left-hand side. I combine 16 and 8 together. Whoops. Changing all my colors up on me here. There we go. 12x plus 24. And on the opposite side, I still have 5x plus 10. I can't combine anything over here. That's fine. We'll deal with that as necessary. Cool. So now I have the left side fully simplified, the right side fully simplified. Let's start getting rid of x's on one of the sides of this equation. So using our hint, I'm going to get rid of the minus 5x. It's going to give me 7x plus 24 equal to 10. Now I'm going to subtract 24 from both sides. I'm getting 7x is equal to negative 14. Almost done with this. I want to get x all by itself. I'm going to divide both sides by 7. I have negative 14 divided by positive 7, so that's going to give me a negative 2 as my final answer. Be on the lookout for that negative sign, that negative 14. Negative signs are the big thing that get a lot of people, I should say, with these types of problems. So take a little bit of time if you need to write that out or check if any signs are changing. But anyway, this is our second example that we have for going through and eliminating fractions in linear equations. Now the second part of what we're going to be going through is working with how to eliminate and get rid of decimals in an equation. I will note that this is just, again, another optional process that you can use to eliminate decimal. You do not have to do this, and there's actually about 2 or 3 other ways that you can go through and solve these problems that aren't using this particular method. I'm going to showcase those a little bit with each of these examples. So number 1 here, we're going to go through it a couple different ways just so you can see the different options that are available to us. And similarly with number 2, we'll look at that 1 or 2 different ways as well. Don't want the video to run too long, but we'll see if that ends up happening or not. But I do want to note that we do not have to follow this, and there are other options that are available to go through and solve these things. So if we're going to follow this suggested process, now what we need to do first is rewrite each decimal as an equivalent fraction. So for instance, the decimal 0.07 could be rewritten into the fraction 7 over 100. So we would do this with all of the decimals at the very beginning of the problem, effectively converting everything into a fraction problem. And then we just went through and had some steps to eliminate fractions, and we basically just referenced those to go through and get to our final answer. Again, there's nothing wrong with this method. You're welcome to use this. I'm going to show you guys 1 or 2 other methods as well. You're welcome to use them, modify them, or just work with these problems written out as decimals and use your calculator, especially for the multiplication and division steps, to get to your final answer. So there's nothing wrong with that. Now, I do want to make a note with example 2 of one of the ways that you can rewrite this thing, specifically this front part. This is 0.5 times the quantity a minus 5. If I was going to rewrite this thing into a fraction, what I can do is start with this decimal first. This 0.05 becomes 5 over 100. I can then rewrite this a minus 5 to be a minus 5 over 1. I now have a fraction times a fraction here. This thing, when I multiply it together, gives me 5 times a minus 5 all over 100. And so now I have this thing written as one single complete fraction. We'll go through and see this in the example in a bit more detail. But otherwise, let's jump over and see, number 1, a couple different ways we can go through and solve this thing, and then go from there. So with our first example that has decimals showing up in it, let's follow the process that we were originally given and get to our final answer that way. So first things first, we're told to rewrite each decimal as an equivalent fraction. So this is 0.6y. This is going to become 6 over 10y. And the 3 and the 9 are going to stay exactly as they are. Now again, I'm looking at all of my fractions in this problem and saying what is the lowest common denominator between all of them. And I really only have 10 and the invisible 1 that's sitting below these two things. So the lowest common denominator is going to have to be 10 amongst all of them. So this means that each of our terms, whether they have fractions in them or not, going to have to multiply by 10. Because again, our goal with this whole step is to eliminate fractions, not have to worry about them. Okay, so we get this left one here. I have 10 in the numerator spot, 10 in the denominator spot. Cross-canceling makes those each become 1. 1 times 6 is going to give me 6y. 10 times 3, that's going to give me 30. And then 9 times 10, that's going to give me 90. And now I have a fraction with no decimals or any fractions. Fantastic. Now I can go about solving this thing just like we did in the past. So I'm subtracting 30 from both sides. I'm getting 6y equals 60. Then I divide both sides by 6. I'm getting y is equal to 10. And there we have our final answer. Now we're going to go over a couple different ways that you could solve this problem. This method is certainly not required. It's just one that the book that we are using for this particular class specifies that this is the method that we use to go through and find our final answer. So we're going to go through this exact same problem 1 or 2 different ways just to show that there are some different methods to get to your final answer. You're welcome to use any of them as you're going through these problems, but I'd make sure that you're picking one and then sticking to that. We don't want to cross the streams of our processes. That's where things go horribly wrong. let's take another look at how we could solve example 1 here. Okay, so let's go through an alternate method that we can use to get to our answer for number 1. Remember, you can use this method or you can use the one we've used in our previous chunk of the video, but either one will work to get you to the final answer. So for this one, we are going to instead eliminate decimals. We're not going to do any conversion into fractions. We're going to leave things as decimals and then eliminate the decimals from there. So the way we do that is we want to look at all of the decimals in the problem. In this case, we really only have the 0.6 showing up. Technically, this is 3.0 and 9.0, but I don't have anything that's significant in the decimal place with these two numbers that's going to work for what we're trying to do here. This 6 is in the decimal place, which means that we are going to be able to use this method to eliminate decimals here. Now, I want to see which of my decimals has the most decimal places in it that are significant. And in this case, our first decimal here has one decimal place that is significant. It technically has 0, 0, 0, 0, 0, 0 going on forever after it. Same thing with the 3 and same thing with the 9, but that doesn't actually change the value of any of these numbers in here. So my first one has one decimal place. Fantastic. That means that I am going to multiply every single term by effectively 10 to the first power, meaning I'm going to multiply everything just by 10. And again, I think it's worth writing this out for yourself just so you can see it once, but it's everything times 10. That times, whoops, let's make that a better 10. There we go. And then that thing times 10. Now with the decimal and value here, you're welcome to use a calculator. Do 0.6 times 10 if you would like to. That's going to give us 6y plus 30 is equal to 90. And we see from here this is the exact same thing that we got in our previous problem, or the previous time that we went through this, and we'll get to our exact same answer here. So just want to note that this is an alternate method that you can use. You certainly do not have to use it, but I think it's very handy to get through these things using this method of just straight up eliminating the decimals before we do anything else. I do want to show you one more method, so we will jump over to do that really quick, but just note that we have this method at our disposal as well to solve these types of problems. Our last method that we have is essentially saying, I have decimals showing up in this problem, I don't really care, I will just deal with them and leave them in the problem. I'd recommend if you are going to take this approach, use a calculator because these numbers can get fairly gross pretty fast, and I don't think it's obvious how to multiply or divide or whatnot with decimals and get to the final answer. So I'm going to be doing a lot of these calculations off screen, but I'm just using a calculator to get to the final answers and calculations along the way. So I'm trying to get this y term all by itself, so I'm going to subtract 3 from both sides. I'm getting 0.6y is equal to 6. I don't want 0.6y, so I'm going to divide both sides by 0.6. Divide both sides by 0.6. And then using a calculator, I'm going to enter in 6 divided by 0.6, and I'm getting 10 is my final answer. So same thing we got in our other two methods, but just wanted to show that there are a few routes you can take to get to your final answer with these types of problems. You're welcome to choose any one you would like as you're going through these. Now looking at our second example for working with decimals, I'm going to try and go through this a little bit quickly because I do want to show you the two main ways that I would recommend going about solving this problem. Our two ways are working with this thing, everything as converted into fractions, and then the second one we're going to go through and leave everything as decimals, but eliminate the decimals just to see how that process is done. So, converting everything into fractions. This first part here I think is the trickiest. I'm going to convert this 0.05 into a fraction. That is going to become 5 over 100. It's still being multiplied by this a minus 5 here. This 0.25 as a fraction is going to end up being 1/4. And this 3.05 is going to become 61 over 20. If you have a graphing calculator, I highly recommend that we use the mathfrak button sequence to get to our fully reduced final fraction answer to do that quicker. I'm looking at this and I still have grouping symbols showing up over here. So I basically have this thing in parentheses all as over 1. So 5 times this set of parentheses is the same as saying 5 distributing through, and the result going into the numerator of this fraction. So I would get 5a minus 25, all divided by 100. Nothing else has changed in this step. I'm just bringing everything else down exactly as it was. So now I have everything written out as fractions, which is perfectly fine. That was our original goal and part of our process. So now I need to determine what is the lowest common denominator between these three fractions. And in this case, the smallest number that 100, 4, and 20 can all multiply into is going to be 100. So everything is going to multiply by 100, regardless of whether it is or is not a fraction. Thankfully, everything here is a fraction, so we don't need to worry about numbers getting too ridiculously big, but that can still happen from time to time. So I have 100 here, and I have 100 in the denominator spot. These are going to cancel. They each become a 1, which means this first term becomes 5a minus 25. This 1 over 4 and the 100, the 4 becomes a 1, the 100 becomes a 25. 25 times a, that's going to give me 25a. And on the other side, I have 20 in the denominator spot. I have 100 in the numerator spot. Both can be divided by 20. The 20 becomes a 1. The 100 becomes a 5. And then 5 times 61, that's going to be 305. Showing up right there. And again, what's great about this is now fractions are gone, and we can go through and solve this thing like we would normally. So if I'm combining like terms, I end up getting 30a, it should be 30a, not 3a. There we go. 30a minus 25 is equal to 305. I'm then going to be adding 25 to both sides. And if these numbers are starting to get a little too big for you and you can't do the mental math that goes along with it, there's absolutely nothing wrong with that. Again, I'm using a calculator off screen here to go through and solve these things and get to my answers with these larger numbers. There's nothing wrong with doing that as well for you. Dividing both sides by 30, I want the a all by itself. That should give me a is equal to, I want to say that's going to be 30. Thank you, calculator. Or not 30, it should be 11. Oof, not a good day for mental math. Here we go. We should be getting 11 as our final answer using this process to get through number 2. All right, so I want to go through an alternate method that you can use to solve number 2. This is going to be similar to what we did with our first example where we eliminated the decimals by multiplying by some multiple of 10 in this problem. Before I do that and before I eliminate decimals, I need to make sure that I've gotten rid of all grouping symbols, brackets, parentheses, absolute value signs, anything like that. And I need to make sure I've gotten rid of any and all exponents in the problem. Thankfully, we don't have any exponents in here, which is good, but I do have these parentheses showing up. So this 0.05 needs to multiply through to everything inside that set of parentheses. So I'm going to get 0.05 times a, and then if need be, again, use a calculator, 0.05 times negative 5, that should give me negative 0.25 there. And everything else is staying the exact same. I don't have any parentheses or anything like that showing up. It's fantastic. Now I need to determine which of these numbers has the most decimal places that are significant. So I'm seeing this one has 2 decimal places, 2 decimal places, 2 decimal places, 2 decimal places. Okay, well, they all have 2. That's fantastic. So that means that I can multiply every single one of these numbers by 100, essentially 1 with 2 zeros at the end of it, and that's going to eliminate all of these decimals, and I'll just get whole numbers left over at the very end. So again, each individual thing, whether it is or is not a decimal, is going to multiply by 100. Now we notice, great, this is pretty much where we were at with our previous method to get to our final answer. So again, two perfectly reasonable routes you can take to get there. When you're working through these problems, I don't really see much of a reason to require one method over the other. They both work. So as you see problems like this showing up, pick one that you feel most comfortable with, and then just commit to that from start to end. I think it's very important as we're going through these to not deviate from the method that we've selected. Very often people will start using one method correctly and then incorrectly apply a different method, which will make wrong answers tend to show up more often than not. So make sure as you're going through these are two methods for solving this particular problem or any of the other ones. Make sure you do pick the one that you like and want to use, and then just commit to that all the way down to your final answer. As a quick recap of everything that we went through, we had two suggested processes from the book on how we work with fractions in equations and how we work with decimals in equations. Remember that to use either of these methods, we need to make sure that we have eliminated, or at least worked through, all grouping symbols and exponents. If you have any grouping symbols or any exponents left over before you dive into either of these processes or the other processes that we went through on top of these, then you're not going to be able to get to the right answer in a reliable way. There's a lot of room for error within that, and while we can go through and get to the correct answer if we're doing that, I tend to find that if we avoid trying to jump steps, we tend to get the correct answer more consistently. So write these down as necessary for yourself. We're going to go ahead and move on to some additional group problems if you were doing this with someone else, or if you want to give these some practice on your own. Got some practice problems here. I'd recommend trying a couple of the different alternate methods that we went through as well. I think that can be really nice to see that there are multiple routes we can take and just figure out which one is going to work best for you or one that you're most comfortable with. We'll scroll down here. We have our final answers. Might be a couple typos showing up within this, as you saw with one of the earlier problems, but these should be reasonably close to the final answers, I'm pretty sure, for most of them. But otherwise, that's going to do it for the 2.5 material.